Okay. 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 Good afternoon, all. Okay. In last lecture, we have discussed effect of the alloying elements on the properties of steel, and after that, we have discussed the classification of the steels depending on the different basis. Now, after that, we will move towards the next type of the steel, that is the alloy steel. Now, the alloy steels are classified, that classification we have seen in a brief at the start of our chapter, that is the in the classification of the metallic material. Alloy steels are classified in tool steels and stainless steel. And now here, just in that classification, we have discussed the names and how that classification is done. Now here we will discuss that in the brief, that is along with the how on which basis this classification is done, and we are going to discuss the properties and composition and their specific applications according to for each type. We are going to discuss their composition, properties, and applications. Okay, now this, whether it is visible clearly. Now this tool steels. Okay, these tool steels, specifically why this name is given as tool steel here, because these steels are used for different working operations, or they are used as a tool to perform different kind of the operations which we are using in the industry to give a material desired kind of the shape. And the same steels are used for doing the cutting operations also. That's why these steels are termed as the tool steels, because we are using these tool steels to manufacture the tools to perform the different manufacturing operation. That's why these steels are termed as the tool steels. Now, these steels are classified in four different types depending on their use. That is in four different types depending on their use or their different applications. The first type you can see here, that is the cold worked tool steels, then hot worked tool steels, then high speed tool steels, and special purpose tool steels. Now, on which basis this classification is done? This classification is done on the basis of their application, on the basis of their application or use. This classification is done: cold worked tool steels, hot worked tool steels, high speed tool steels, and special purpose tool steels. Now, these cold worked tool steels are used for performing the different kind of the cold working operations. These hot worked tool steels are used for performing different, what you can say that different hot working operations. Now, what is the difference between cold working operation and hot working operation, or just you can simply say that cold working and hot working? What is the difference between the cold working and hot working? Now, uh, for any kind of the material, or any specific material, or any kind of specific metal, there is some temperature ranges or some terms used. The operations, first I will tell you what is the cold working and hot working. Now, the operations which are conducted below the recrystallization temperature of that particular metal or alloy, that kind of operations will be termed as the cold working operations. And the operations which are performed above recrystallization temperature but below the melting point of that particular metal, that will be termed as hot working operation, or simply hot working. Now, here question will arise: what is the meaning of the recrystallization temperature? Okay, what is the meaning of recrystallization temperature? Then, for what is the meaning of recrystallization temperature, I will tell you that uh, whenever you are doing the heating in a material, from suppose you have taken any metal or alloy and you have started providing gradual heat, then its temperature will rise. Then at a certain amount of temperature, when it reaches to a higher point, means suppose above 500 degrees Celsius, above suppose 550 degrees Celsius, or about 600 degrees Celsius, whichever grains are present in that particular metal or alloy, they will start breaking, or the older grains will get deformed, or older grains will get uh, breaked, and formation of new grains will occur. Okay, and the temperature at which old grains breaks and formation of new grains will occur, that temperature will be termed as recrystallization. Means there will be some change in its crystal arrangement, that is, it is changing its for means which you can say that orientation of the grain. Okay, orientation of grains will change. That particular temperature will be termed as recrystallization temperature. And whenever you are performing an operation below this recrystallization temperature, means before grain change occurs, all that operations will be termed as cold worked operations, or you can say that in simple way, it is termed as the cold working, because we are performing the operations below recrystallization temperature, means before formation of the new kind of the grains, that will be termed as cold working. And whenever you are doing an operation above that recrystallization temperature, means when formation of new grains occurs, and before melting, before that metal or alloy will get transformed to the liquid state, in between that you are performing the operation, that kind of operation will be termed as hot working process, or simply hot working. Okay, so this is the difference between the cold working and hot working. And the operations which we are performing below the recrystallization temperature of that metal or alloy, that will be termed as cold working. And the process or operation which we are performing above recrystallization temperature and just below the melting point of that particular metal or alloy, that will be termed as hot working. And what is the recrystallization temperature? The temperature at which the old grain breaks and formation of new grain occurs, that temperature is termed as the recrystallization temperature. So the tool steels are classified in two basic types, that is the cold worked tool steels and hot worked tool steels, depending on their applications. The tool steels which are used for cold working operations are termed as cold worked tool steels, and the tool steels which are used for hot working operations are termed as hot worked tool steels. And what is the meaning of high speed tool steels? Now these high speed tool steels, these are having very high hardness, and they maintain their high hardness at the higher temperature range also, means about you can say that 500 degrees Celsius or above 500 degrees Celsius, or at 550 degrees Celsius also, they will provide you high hardness and very high strength. That's why that you can use these steels at that particular higher temperature range, means you can use that steels at the high speed also, because it is sustaining at the, means it is providing the desired hardness and strength at the higher temperature ranges also. That's why you can use that steels at the high speed application. That's why it is termed as the high speed tool steels. The last type, that is the special purpose tool steels. Now here we are using, depending on their some specific applications that I will explain you later. Depending on some specific application, some steels are categorized in these special purpose tool steels, and these are classified in different ways depending on that whichever applications we are using, that we will discuss in the later half of this lecture or in the next lecture. Now I have explained on which basis these tool steels are classified in four different types, that is cold worked tool steels, hot worked tool steels, high speed tool steels, and special purpose tool steels. And after that, here I have marked the their subtypes also. That is, in the cold worked tool steel, four types are there. Okay, depending on their composition and depending on the medium of hardening used, these cold worked tool steels are classified in four different types: water hardening tool steels. Here you can see water hardening tool steels, air hardening tool steels, oil hardening tool steels, and high carbon, high chromium steels. This classification is done on the basis of the medium used for hardening and depending on some specific composition or depending on some specific alloying element. Okay, now the hot worked tool steels are classified in three different types: chromium type, tungsten type, and molybdenum type. This classification is done on the basis of principal alloying element. Now in alloy steels, you have learned that in the alloy steels different alloying elements are there, and whichever alloying element is present in the larger amount, that alloying element will be termed as the principal alloying element. Now depending on that principal alloying element, hot worked tool steels are classified in chromium type. Chromium type means here the principal alloying element will be chromium, means chromium will be present in the larger amount, means after the parent metal this chromium quantity will be more here. That's why it is termed as chromium type tool steel or chromium type hot worked tool steels also. Then tungsten type tool steels, here this tungsten will be present in the larger quantity, or it will be termed as the principal alloying element here. That's why it is termed as tungsten type tool steels. Then molybdenum type tool steels, here molybdenum will be principal alloying element, that is alloying element which is present in the largest proportion. Okay, so depending on the principal alloying element, hot worked tool steels are classified in chromium type, tungsten type, and molybdenum type. In the same way, high speed tool steels are classified in two types: tungsten type and molybdenum type. This classification is done on the basis of percent percentage of the principal alloying element. Here tungsten will be principal alloying element, and here molybdenum will be principal alloying element. Now the last classification, that is special purpose tool steel classification in S series, then L series, F series, and P series. Now, this S series stands for shock resisting tool steels. Shock resisting tool steels, depending on their particular application, this will be termed or this will be categorized as S series. Whichever applications are there, that we will discuss later. Just try to understand the names. S series means shock resisting tool steels. Then L series is low alloy tool steels. Then F series is carbon tungsten tool steels, and P series is known as the mold steels. Okay, so depending on their different applications or some specific compositions we have used here, depending on that, here special purpose tool steels are categorized in four types: S series, that is shock resisting tool steels; L series, that is low alloy tool steel; F series, that is carbon tungsten tool steels; and P series is known as the mold steels. Okay, so this is the brief classification of the tool steel. Now, as far as your examination is concerned, they may ask you the brief classification. Then you have to draw this chart as it is, and you have to explain the basis of the each classification. Means tool steel has four types, on which basis it is categorized, and on which basis its subtypes are made. That you have to explain here. And as far as your examination is concerned, generally they are asking you the particular, means they will provide you particular name. That is, suppose for example, they will provide you water hardening tool steels. Then what they will ask you, write the composition, properties, and application of, and they will provide you any two or three names from this tool steels. Compulsory minimum two tool steels they will ask you in the examination. Out of these, I think approximately 13 subtypes are there of these tool steels. Out of these 13, minimum two subtypes they will ask, and what they will ask you, you have to write composition, then its properties, and then its applications. Okay, minimum two, and maximum sometimes they have asked five or six types also. Means at least 6 marks will be there for this tool steel point. minimum 6 mark question compulsory will be there, and maximum you can get 12, or sometimes you will end up with the 14 marks also from this only. Okay, now we will see one by one. Now first we will discuss with the cold worked tool steels and its different four types. Then we will go in the brief about their composition, their properties, and their different applications. First of all, please write down this chart. I will wait for 2 minutes here. Please write down this classification chart. After that, we will move towards the next point, that is the types of the cold worked tool steels. After completion, if you are having any query, please ask me the questions, or you can put that in the chat box also. If you are not having any query, and then after draw this chart, and after completing the chart, put in the chat box that you have completed the chart. Okay, If you have completed, then we will move towards the next slide. Okay. Now, this is the cold worked tool steel. Now, already I have discussed this that these steels are used for the cold working of metals or the particular alloys, that is performing the cold working operations, that is the operations which is carried out below the recrystallization temperature of that particular metal or that particular alloy. Now, regarding the properties of the cold worked tool steels, now these are some properties, these are common properties that you can add in all four subtypes. Okay, whichever four subtypes are there for cold work tool steels, so this is the common property for all of them, that is the cold work tool steels have very good hardness and very good wear resistance. But here one condition is there for this cold work tool steels. They will provide you very good hardness and very good wear resistance, but at the lower working temperatures or lower working temperature conditions. If the temperature is very high, then they will be not able to provide you the required hardness and require wear resistance at the higher temperature. That is the very important property. Just writing that it is having very good hardness and very good wear resistance, this is not sufficient. You have to write like this, that is it will provide they have high hardness and high wear resistance, but at the lower working temperature conditions. All four types you can write this property. This is the common property for all of them. And one in the second property you can write that these all these steels can be used for doing the cold working operations for the particular metal or particular alloy. Then here in the cold working tool steels, some of the cold working tool steels, in that some cold working tool steels they may be just plain carbon steels, means no other alloying element may be there. Okay, without alloying element that steels will be there, means you can simply say that they are the plain carbon steels, means carbon steels without any alloying elements. That's why as no alloying elements are there, some of the cold worked tool steels are very cheap, or you can say that they are not expensive. Okay, so these are some of the properties, means very important properties. They will provide you very good hardness and wear resistance, but here important point is that they will provide these properties at the lower working temperature conditions. Then all these steels can be used for cold working operation of the metals or different alloys. Then these steels generally you can say that some alloying elements may be there, but some of the cold worker tool steels are just plain carbon steels, no alloying element will be there. Okay, that's why their cost is very less. All the cold worker tool steels are less expensive, or you can say that their cost is very less. These are the properties. Then these cold worked tool steels, as you can see clearly in this slide, these are classified in four different types. Now this classification is done on the basis of their hardening characteristics or hardening properties. Okay, these are classified in water hardening tool steels, then oil hardening tool steels, air hardening tool steels, and high carbon, high chromium steels. Okay, in bracket, their subname is I have written there, that is W series. Water hardening tool steels are also known as W series steels. Oil hardening tool steels are also known as O series steels. Air hardening tool steels are termed as A series or denoted by A series, and high carbon, high chromium steels are denoted by D series. Now we will see one by one. First, we will discuss the water hardening tool steel. Okay, this is the first type. Now, whenever any kind of you have to make an habit of writing the description in the definite order or pattern like this. Your pattern will be like this. for any kind of the steel. Okay, first you have to write their composition. After writing the composition, you have to write down their properties. Then after writing the properties, you have to write down their types, if any. Means some steels may be having their subgroups or subtypes. Then you have to, after writing composition properties, you have to write that types. And at the end you have to write the applications. Okay, this common format you have to follow for this kind of writing the answers for these particular questions. Okay, in examination question will be only like this. They will provide you the name of any kind of the steel, that may be tool steel from, or it may be a stainless steel, or it may be plain carbon steel also. Your answer will be like this. You have to write the name of that given steel, then its composition, then properties, then if any there is further classification or subtypes are there, then you have to write down the types, and at the end you have to put the applications. Okay, now here the marking scheme also I will tell you. If suppose in examination they have asked you water hardening tool skills, and they have asked you to write composition, properties and applications, then composition and properties togetherly will carry 1 mark, and applications separately carries 1 mark here. Means this one slide will be for 2 marks. Okay, this will be the marking scheme for your university examination. I am telling you that in the same way, there may be 5 to 6 name given, or maximum they will ask you 7 names will be there. Okay, 7 names they will provide you from this total chapter. 7 types of any 7 steels they will ask you, and you have to write their composition, properties, applications, and if any subtype is there, that you have to mention there. Okay, now we will discuss here firstly, that is water hardening tool steel. Now in the first point you have to write the composition here. Water hardening tool steels, these are denoted by the W series. And as far as their composition is concerned, these are the water hardening tool steels are the, generally these are plain carbon steels. No alloying element is present here. Okay, plain carbon steel means only iron and carbon will be there as an alloying element. Okay, no further extra alloying elements are there. Plain carbon steel means alloy of iron and carbon as alloying element. Okay, no extra alloying elements will be there. Means it is a plain carbon steel, and plain carbon steel containing the carbon percentage within the range 0.6% to 1.4%. Okay, means clearly you can see that these are the plain carbon steels having high percentage of the carbon, or simply you can say that these are high carbon steels. Okay, carbon percentage will be more than 0.6%. That will be your composition. Plain carbon steels with high carbon content of 0.6% to 1.4%. Now in the next point you have to write the properties here. In the properties, already I have discussed it with you that the one common property for this cold worked tool steel, I think 2 or 3 we have discussed in the previous slide only. That is, they have very high hardness and very high wear resistance, but at the lower temperatures. And as their no other alloying elements are present or extra alloying elements are not there, their cost is very less. These properties we have discussed already, and in that we have to add one more extra property here, that is hardening of these kind of these steels or these tool steels. Hardening is done by using the water quenching. Hardening means, or you can say that here water quenching is nothing but, I will tell you in the short way. A metal or alloy is taken, it is heated in the furnace. Suppose at the higher temperature ranges, means above 900 degrees Celsius, 900 to 1000 degrees Celsius, it is heated at that much higher temperature. Then after that, that metal or alloy is taken, and it is suddenly cooled, or directly it is taken and dipped into the water. Okay, that will be termed as the water quenching. We are heating the particular metal or alloy at the higher temperature ranges, that is above 900 degrees Celsius or 1000 degrees Celsius. And after heating, we are taking that component from the furnace. All this heating process will be taken done in the furnace only. And after that, using the suitable safety instruments, we are collecting that component, and we are taking it and directly dipping that metal or alloy in the water. This quenching will be this quenching or this cooling process, simply you can understand that this is quenching means nothing but you can simply term it as a cooling process. Here we are doing the water quenching. Okay, from the higher temperature, that 900 degrees Celsius, directly we are dipping that component in the water, cold water. Okay, this will be termed as the water quenching. Then during this, what will happen, we are suddenly cooling from 900 degrees Celsius to the room temperature. Then what will happen, hardness of that material will get increased, hardness will get improved. Now here we have done this hardening process. This will be termed as the hardening process. And here the hardening process is done by using the water medium or water quenching. That's why these tool steels are termed as water hardening tool steels. Are you getting this point? Why the name is given as water hardening tool steels? Because to perform the hardening of these tool steels, we are doing the quenching or cooling process by using the water medium. That's why it is termed as water hardening tool steels. And due to this only, they are designated or denoted by using the W series only. W stands for water here, water hardening tool steels. Okay, so this is the very important property, that is hardening is done by water quenching, and hence these are termed as water hardening tool steels. Okay, after the writing these properties, few common properties will be there, like hardness and wear resistance is very good at lower temperatures, their cost is very less. And after that you have to write this property, that is hardening is done with the or by using the water quenching, hence the name is given as water hardening tool steels, and they are denoted by W series. And in the last point you have to write the applications where these tool steels are used. Now, these water hardening tool steels are used for manufacturing of blanking dyes, the dyes which are used in the blanking operation, then dyes which are used in the threading operation, that is manufacturing of the blanking dyes, manufacturing of the threading dyes, then manufacturing of the tube drawing dyes, then manufacturing of the different types of the drills, manufacturing of the different types of the tools which are using which we are using in the forming operation, then different types of the hammers, chisels, different types of the woodworking tools, shear blades, knives, razors. All these are manufactured by with the help of this water hardening tool skills. Okay, and generally you can say that the lots of instrument which are or accessories which we are using in the workshop, that is the drills, hammers, chisels, then woodworking tools, uh, that are manufactured with the help of this water hardening tool steels. Okay, so this is the first type of the cold worked tool steel, that is water hardening tool steels. Okay, is it clear for all of you? Please reply me. Sunil, Sunil is there? Sunil Sadud, are you there? Roll number 62. Please give me reply this, whether this point is clear.
Yes, sir.
Okay, Pranay Disle. Okay, any other person?
Yes, sir.
It is clear. Okay, from girl side. I'll randomly ask. Is this roll number six? Roll number six is there. Madhuri. Roll number six. Why you are not giving replies? Roll number seven. Namrata Parvat.
Yes, sir.
Okay, okay. All points are clear.
Yes, sir.
Okay, okay, okay. Thank you. Okay, then now we will move towards the next type. The second type of the cold work tool steel, that is the oil hardening tool steels. Okay, now these oil hardening tool steels are denoted by the O series. Now, why this O letter is given here, that I will explain in this slide only. Now, first point you have to write the composition. Now, in the composition, if you are not able to remember the exact percentage of carbon, then you can also write like this: high carbon steels. Okay, means depending on the range, you can write. Otherwise, you have to mention the exact percentage, that is uh, from carbon will be there from zero point 0.6 to 1.5, like this. Okay, otherwise you can write like this also: high carbon steel with addition of with a small amount of alloying elements. And alloying elements here, very few alloying elements will be there, that is tungsten, manganese, chromium, molybdenum, and vanadium. Okay, in the first type, that is the water hardening tool steel, no alloying elements are there. Okay, only plain carbon steel is there. Okay, means iron and carbon. But in this oil hardening tool steel, here along with that iron and carbon, other alloying elements are present in the small amount, and that carbon steel will be, content of the carbon will be at the higher range, that is more than 0.6%. High carbon steels with small amount of alloying elements like tungsten, molybdenum, chromium, vanadium, and manganese. Okay. After writing this composition, you have to mention the properties. Here in properties, you can write like this. The first few properties are common for all four cold worked tool steel, that is they are having very high hardness and wear resistance at lower temperature ranges, and their cost is on the lower side, or they are not expensive. After writing that, you have to write for each, you have to write related to their hardening. Okay, now here these oil hardening tool steels, as compared to the water hardening tool steel, their hardenability, okay, their hardenability is better. Hardenability is better. The and here to perform the hardening process, we are using the oil medium, or here oil medium is used. Hence, these kind of the tool steels are termed as oil hardening tool steel, because to perform the hardening process, oil medium is used. And during this which what you can say, that during the hardening process, whichever amount of shrinkage, and you can say that whichever amount of shrinkage, or in other words, uh, you can say that the distortion, whichever amount of distortion is there during the hardening process, that distortion is very less in this oil hardening tool steel. That's why these are termed as, here I have written some capital letters in the bracket, OHNS. Okay, its long form is oil hardening non shrinkage tool steels. Oil hardening non shrinkage tool steels. And why this name is given? During the hardening process, distortion means change in their dimensions, you can say that distortion or shrinkage amount is very less. That's why these are termed as oil hardening non shrinkage tool steels. Oil hardening non shrinkage tool steels. And medium used for hardening is oil. That's why these are termed as oil hardening tool steels. And because oil medium is used for their hardening. These are denoted by O series. These are denoted by O series. Now different applications. Oil hardening tool steels. These are used for manufacturing of the different dyes, that is the blanking dye, forming dye, then different types of the cutting tools, and then different types of the manufacturing of the different types of the shear blades, or some particular master tool you are using for conducting some specific applications. Then it is also used for manufacturing of the different gauges. Gauges means nothing but here you can say that the different measuring, for manufacturing of different measuring instruments also, that is termed as the gauges here. Okay, so these are the application. Means first you have to discuss the composition, properties, and then application. So this is the second type, that is oil hardening tool steel, denoted by O series, and it is also termed as capital letter OHNS, that is oil hardening non-shrinkage tool steels. And there are applications: blanking dyes, forming dyes, shear blades, some cutting tools or different master tools depending on the desired applications, and some gauges are manufactured with the help of this oil hardening tool steels. Then after this discussion of this water hardening and oil hardening tool steel, the third type is air hardening tool steel. In the cold worked tool steel, this is the third type, air hardening tool steels, and these are designated, or these are denoted by the A series. Okay. Now here the first point will be composition. Now in the oil hardening tool steel and in the air hardening tool steel, composition is very much similar. Okay, in both cases high carbon steels are there, and with addition of some of the alloying elements like tungsten, chromium, molybdenum, manganese, like that. Okay, but what is the difference? These in the oil hardening tool steel, here you can clearly see that high carbon steel with small amount of alloying elements. Okay, small amount means less than the 5%. Togetherly this alloying element will be, their quantity will be less than 5% in the oil hardening tool steel. And in the air hardening tool steel, high carbon steels with more than 5% amount of alloying element means togetherly these addition of the alloying element or quantity of these alloying elements, that is tungsten, manganese, chromium, molybdenum, these alloying elements quantity will be more than 5%. Okay, high carbon steel will be there, high carbon steel with more than 5% alloying elements, that will be air hardening tool steel. And high carbon steel with small amount, that is less than 5% of this alloying element, that will be oil hardening tool steel. Okay, for air hardening tool steel, high carbon steel composition will be high carbon steel. High carbon steel is nothing but you have to write 0.6 to 2% or 0.6 to 1.5%, and with more than 5% amount of the alloying elements like tungsten, manganese, chromium, molybdenum. Okay. Now here, after in the properties you have to write, they have very high hardness and wear resistance at the lower temperature ranges. And the next point related to the hardening, you have to write here, hardening is done with the help of air medium here. Okay, means in other words you can write like this: hardenability of air hardening tool steel is more. Okay, as we are moving, water hardening tool steels will be having lesser hardenability, then oil hardening tool steel will be having more hardenability as compared to the water hardening tool steels, and air hardening tool steel will be having highest hardenability out of these three types. And hence here medium used for hardening is the air medium, and these tool steels are termed as air hardening tool steels because whichever hardening means during the cooling, here we are using the air medium for doing the cooling process. Okay, Then in oil hardening tool still we have used oil medium for doing the cooling or quenching operation, and in air hardening tool still here quenching or cooling operation is done in the air medium. That's why these tool stills are termed as air hardening tool still, and these are denoted or designated by A series. A series air medium is used for the cooling. Okay, air medium is used for doing the cooling during the hardening process. Now, after writing this, the last point in this particular air hardening tool still is the applications. Now, here applications, thread rolling and slitting dies for manufacturing that thread rolling and slitting dies. Then drawing dies to perform different drawing operations. Dies are required. That dies are manufactured with the help of these air hardening tool stills. Then some intricate dies. Intricate dies means here you can say that difficult shape. Okay, difficult shaped dies are manufactured by this air hardening tool steels. Then manufacturing of gauges, different gauges or measuring instruments, and different punches. Okay, these are manufactured by help of this air hardening tool steel. This is the third type. Then after this third type, the last type in this category, that is cold worked tool steel, is HCHC steel. Okay, it is denoted by HCHC steel, or it is also denoted by D serial. HCHC stands for high carbon, high chromium steels. Here for chromium also only one letter C is used. Okay, HCHC steels, or it is known as high carbon, high chromium steels. Now, your first point in this will be related to the composition. Now, these steels are again, these are high carbon steels with carbon percentage here more than 1.5. Sometimes carbon percentage, in some rare cases, carbon percentage may be more than 2%. Maybe it may be more than 2% also. It may be more than 2%, and that also considered in this HCHC tool steels. Okay, now again this high carbon high chromium steels, these are high carbon steels with carbon percentage more than 1.5, and percentage of chromium is about 12%, and with addition to these, small amount of other alloying elements like tungsten, molybdenum, and vanadium is present. Okay, this is the composition. High carbon steels with carbon percentage more than 1.5. As here you have written the name high carbon. Okay, high carbon is name. High carbon, high chromium. High carbon means carbon more than 1.5%, and high chromium means carbon is more or about 12%, and small amount of other alloying elements, like only these three alloying elements may be there: tungsten, vanadium, and molybdenum. Okay, this is the composition. Now, regarding its properties, here you can see that now I will explain. Before that, mm, I will go for these properties first. It is having CD point number 4, high hardness and high wear resistance. Okay, high hardness and high wear resistance. Then it is having very high hardenability, and here during the hardening process, very less distortion is there, and for doing the hardening process, oil or air medium is used for quenching here. Okay, regarding the properties, it is having very high hardness and high wear resistance and high hardenability. These are the properties. And the last point is the application. Now here different dyes, that is dyes required for drawing operation, blanking operation, forming operation, coining operation, thread rolling operation, trimming operation, these different dyes are manufactured by using this high carbon high chromium steel only. That is drawing dyes, blanking dyes, forming dyes, coining dyes, thread rolling dyes, trimming dyes, all these are manufactured with the help of high carbon high chromium steels. Then different kinds of the shear blades, punches, then cold forming tools, cutting tools, different types of the gauges, All these are manufactured with the help of this high carbon and high chromium steels. Okay, so all these in this way, in this lecture we have discussed or we have completed the we have started the tool steel part, and in that we have completed the cold worked tool steels. In this we have seen discussed in detail what is the meaning, what is the cold worked tool steel, what are their properties. Then after seeing this, we have discussed there are four subtypes: water hardening tool steel, oil hardening tool steel, air hardening tool steel, and high carbon, high chromium tool steel. That is four subtypes of cold worked tool steels we have discussed along with their composition, properties, and different applications. Okay, in this way, I am about to conclude this lecture. In this way, we have studied the cold worked tool steels and their different types along with their applications in this lecture. Okay, now wait, I will first stop the recording. I have some announcements for you. Okay, now I will conclude this session here.